Okay. Hello, everybody. I'm George Kola from Google. I'm going to be talking about in-band management agent. So, what's an in-band management agent? So, the definition is that it's a piece of software that actually runs on the host CPU and enables system management. An alternative to an in-band management agent is an out-of-band, typically like a BMC-based solution. What are the use cases for it? Typical use cases are monitoring, telemetry, firmware update, failure prediction, and self healing. Example of self healing would be memory poison containment and also DIM post package repair. Why in band? Right? So we already have like an out of band BMC based solution, but why do you need in band, right? Certain monitoring and management is actually available only in band. An example is that if you have host kernel or software metrics, those are available in band only. Host CPU metrics, PCIe error metrics, and memory check exceptions, memory poison containment, and memory post package repair. And other big advantage is that you have direct high bandwidth connection to PCIe. So if you have like a bunch of GPU cards and you want to update firmware on them in parallel, higher bandwidth helps. We also have higher processing power of server CPU for certain use cases like live debugging. That would help. And finally, you can actually augment out of band, right? There could be machines without BMCs or machines with like limited microcontroller. And you can also do something like in band on the server CPU works and out of band on CPU failure. And then there is also in band in like management server and processors. Example is like a rack management unit, a switch management processor, or a smart NIC. This is the architecture that we have. So it's a little loaded diagram, so I'll walk through it slowly. So we have a bunch of devices, or actually what we call as device classes, right? We have an agent per device class, right? And the whole thing like runs on an enclave. The whole thing is called an in-band agent, and it actually exposes a redfish based northbound. So we have redfish with some OEM OCP extensions, right? And so what the in-band management agent does is that it activates the agent either dynamically, it does a scan and figures out the devices and has a pre-configured like list from which to activate, or it can be like a static list that is set and it tries to activate them. Right? Agents actually export the telemetry, and the coordinator is there to basically consolidate the telemetry exported by a different agent, right? And the coordinator also provides like a bunch of common functionality. There is no direct access to the hardware, or you may have time based access. And so before accessing the hardware, the agent would talk to the coordinator, and the coordinator would basically give it a lease, right? And the lease itself, the coordinator can actually attain it from the host OS or a management container. So an example would be that a HDD could be locked, and if you want to access it, you basically like get a lease, and then you unlock it, you access it, and then it's relocked back. First question is about agent discovery. So each agent specifies the device class it supports. So an admin, for example, can actually inspect an agent to figure out like what devices it actually supports. An example is that we may not want an agent from like one vendor to access like hardware from another vendor. You can also have static or dynamic activation. So for a given service queue, you may have like a pre-configured list of agents to activate. That is like a totally static configuration. You may also have like a more dynamic configuration where so there is like you have a set of agents, but the coordinator dynamically figures out which agents to activate based on like a PCIe scan or a device scan. This allows some sort of flexibility. You may actually have like a set of agents and different SKUs. You just can ship the same thing to support multiple SKUs. The next part is the telemetry part of the API. The coordinator will actually export DMTF redfish tree with data collected across the different agents. So we'll be working with DMTF on certain additional modeling needed for certain things that is not in the standard yet. The southbound API, we don't actually like mandate a southbound API. So it can be device hardware specific, and we are not actually specifying like a protocol for it. And this is a security architecture. there is no direct access from the agent to the internet or off host, right? Telemetry access is always provided by the coordinator. The coordinator actually limits the data exported. This this helps to basically prevent accidental PII leak. For example, if an agent accidentally exposes extra data, coordinator can actually like strip them, right? And the hardware access is actually enforced by the management container or the host OS, right? You can actually have like a sensitive access which is time limited, right? For example, if you want to read like dim data, you may be basically restricted to basically yearly host boot where there is no PII, right? And coordinator plus like the core library provides primitives to make it easy for you to implement this thing. And finally, like, please join us. We need like all of your feedback to finalize a proposal. As Sami mentioned, we already have a draft specification. We are going about like finalizing it and sending a IMA white paper. We'll also be contributing the code to the open source that is coming in 2023. So this is the links. Yeah, please join us. Yes. Mike, please. Yeah. Yeah, go ahead, Panos.
Can you turn that on? Okay. If I can help, like the IMA is supposed to be complementary to what the BMC can offer, and if we have a very fast pacing hardware evolution, some of the features that we would need for the telemetry of the GPUs, let's say the ML equipment, may not be available into the BMC and may not be wired to be collected from the BMC. So the AMA can complement that and collect it and stream it down the same channel, the same technology that the telemetry would collect for any other traditional, let's say, classic hardware. No, not necessarily. The IMA has like our proposal is a modular architecture where we can plug modules for each kind of hardware that can be accessed from the host system. So it should scale, and my presentation next will be about like combining the data together.
Yeah, it scales. And if I may answer one more thing, right? There are also like more complex systems. You may also want to do like live updates, right? And so IMA actually helps because you may actually like deprovision the device, like or temporarily like make the resource unavailable, update the firmware and make it available. All of it, you can do it live.
Hey, George. Hey, so in this design here, so do you guys see the things like the enclave and the coordinator as being kind of like a single contribution that's out there, and then the device agents are coming from all sorts of sources, or does everyone kind of roll their own, or what's the model you see for implementation?
Good questions. So we'll give a sample things. Yeah, exactly as you mentioned. It will be the device agents people can contribute and hardware vendors can contribute. We'll provide all the glue code, and then it's also that others can also openly like contribute to it as well.
Okay, then follow up. So, what is there some sort of like a signing model, or for attestation of these agents so that you got the good stuff, or how does that work? Could you?
Yeah, exactly. So they're all going to be like signed, and so that there is no like manipulation of the code that actually runs. And there are like depending on like how trusted it is, we can like figure out the exact like details. But a key part is similar to an app, right? So it tells what devices is actually going to access, and it's allowed to access only that, and there is a way to validate that as well.
Can I ask one more? Hey, and then on the enclave, is there any type of sandboxing? How do we protect the host and the host workloads from what's going on in the enclave? Is there any throttling or even measurements so that we know, like, hey, this thing's not going crazy and stealing our real revenue driver for management?
Exactly. So we have ways, basically like a container-based things to limit the resources you can actually use. Thank you. Yes. Yes. Yeah. So the question is that are you hosting the IMA for the bare metal machine as well, right? That is it's a good question. So typically, if it is a bare metal, we cannot run like a full-fledged IMA, right? There is a limited IMA. It may be possible to run if you're allowing like a container to run, but it may not be feasible if it's a fully bare metal. Basically, like the question for the others understand is that a full bare metal is that basically the cloud provider like GCP would allow you to run it on the full hardware. So basically, in that case, you can't actually run anything on the hosts. Yes.
Failure prediction. Sorry. Yeah, like you depend on the in-band agents to provide what kind of telemetry required for failure prediction, or there is also contribution for coming from this work stream.
No, that's just a use case. It's basically yeah. So we can give you example like where we can use it for failure prediction.
Okay.
So that's a future work in case if you want the like
Okay.
exact failure predictions based on devices and data. That will also build upon what like Panos is like going to talk about as well.
Okay. Okay.
Yeah, George.
Yep.
If I could add something, so one of the things we do have an effort in the fault management group where we are working on out of band telemetry and the analysis that you're talking about. And so, my question to you is, have you thought about how the work that we're doing in the fault management group complements this in-band work?
Yes. So there is certain cases where you may need in-band. For example, like memory poisoning containment as an example, right? So where the host has to be involved in like figuring out how to do that, and there is like part of it you can actually do it out of band as well. But I think that is like another nice topic, like combination of both in band and out of band to basically like achieve certain things.
Yeah, and we look forward to working with you all on that.
Thanks.
Do we have time for one more? Yeah?
Yes.
So, Sami, you're going?
No, you can go.
Okay.
I will answer one of the. I will make one more comment, but let Anil.
DIM post package repair is a very interesting concept, right?
Yes.
In order for us to do the host based, we need a physical address information. That means there is somebody has to do translation of host address to physical address,
Yes.
right? What is the thought process in this design architecture? Is the translation will be done by the host, or will we have to have some other service that we have to call in to do the translation?
So you need a code that can do the translation. It's actually exactly as you mentioned. It's like vendor specific and hardware specific as well, right? How the like addresses get mapped. But assuming you have code which can actually do that, can basically that typically runs in band.
Okay, because today is like SMM, which we
Yes.
trying to avoid, right? So
Yes.
SMM cannot be used. So then what would that be?
Yeah. Can you repeat it again? I think I got part of it.
Yeah, basically the address translation, somewhat at the platform level, there has to be some agent at the
That's right.
platform level, right?
Yes.
So traditionally, industry has been using SMM handler, which we are trying to reduce the dependency.
Yep.
So what would be the alternative then?
We actually have code which can actually translate it for you.
So that's a host-based.
Yes. Basically, you can run in host, you can also run out, like if you have the correct registers read, you can actually PCA config space. If you've actually read the registers and pass it along, you can actually do it in the cloud as well.
Okay, yeah, host or cloud.
Yes.
You're not relying on SMM or
That's
DMC.
right.
Okay, very good. Thank you.
Thanks.
Okay, just to add one more comment, right? So basically, you think of whatever is not available in BMC, you want to augment with the IMA, right? So if BMC is so rich that you can do everything you want, then you don't need to use IMA. But if you don't have BMC, you want to still, you can use a lot more things with IMA, right? That's a base promise that we are trying to go after, right?
Cool. Thank you.